Yeah, hello everyone. Good morning. In today's session, we'll talk about Kubernetes volumes. Okay, so how can we use different type of volumes available in Kubernetes? Okay, and then what is daemon sets, what is liveness and readiness? Okay, so all these days, what we were trying to do, we were trying to create one pod. Okay, but if we are trying to store any data inside that pod, right? Inside, I mean, so inside that pod, one container is running. Okay, so inside that container, if I'm trying to save some data, right? So if the container has been deleted, then what will happen? That was a kind of temporary data what we were trying to store. Okay, so we need to have a persistent volume. Persistent volume means, for example, this is similar concept what we have seen in Docker as well. So this is our pod. Okay, and then inside this pod, what we are trying to do, we are trying to create one container. Okay, so inside this container, if you have Nginx or Apache or any other application running, so what generally we do, we try to store some data, right? So for example, I'm trying to store some data over here only. Like for example, what generally we create index.html. So what is happening if this container got deleted? Then what will happen? We are losing the data as well, right? So this is not what we are expecting in the production environments. Okay, because there are two different type of pods available. One is stateful and one is stateless. If you see this, okay, so we have two type of pods. One is stateful and one is stateless. So what do you mean by stateful and what do you mean by stateless? In very simple terms, if I'll explain this, so stateful is something which will store any of the data. Okay, I mean, if any container or any application is trying to store some session on the container, then it can be considered as stateful application. Stateless application means stateless application means any container which is not storing any of the data. So for example, we can assume as database as our stateful applications, because database will always try to store some data, right? So that can be considered as stateful applications. So what is happening? So whenever we are trying to create any container, and if this container is killed for some reason or deleted, so what will happen? We are losing our data. So that is not what we are expecting. So in order to overcome this, we have volumes in Kubernetes. Okay, so again in volumes we can use different type of volumes. So we'll see how can we configure them. Okay, so we have something called, one second, yes, let me disable my WhatsApp. Okay, again in Kubernetes we have different type of volumes. For example, so this is our pod, and inside this we are executing our container. Okay, and I want to store this container related data. So what I will do, I will create one data over here. Okay, this will be my volume. Okay, and this volume we call as mtdir, means we are trying to create one volume inside the pod. Okay, so this container, whatever it is trying to create, so what it will do, this will be stored in the mtdir. Okay, mtdir is a volume type available in Kubernetes. So where this is getting created, inside the pod. Okay, so for example, now this pod has been deleted. For example, this pod has been deleted. Okay, so what will be the behavior of this pod? It will create one more container, right? So it will try to create one more container. So assume that now one more container has been created, and this will be mapped to the same directory or same volume. So what is happening here? So even if this container is getting deleted, then we still have some volume over here, which will be used to this container. Okay, so that's one thing what we can use. But here, if suppose this pod itself is deleted, if container is deleted, then pod is creating one new container. Already volume is available, then it will be mapped to the same volume. Okay, what if the pod is deleted? It will create one new pod, but there will be no volume available. Again, means these kind of volumes are also not the best practice available. Okay, so let us see how can we configure empty dar volume in Kubernetes. Okay, so we have our Kubernetes cluster where one master and two node machines are running. kubectl get nodes. Okay, now let me use this. Okay, so if you see this, we create volume inside a pod to store data related to container. Okay, if the container is killed for any new reason, any reason, a new container will be created in the same pod and the same volume will be attached to the container. Okay, for example, this is our YAML file. So let me copy this. vi emptydir.yaml. Let me configure with this name and then paste. Okay, so these are the four common sections what we have seen all these days. Okay, so this is pod and this is our container. Okay, this will be the container name and the image what I'm trying to use is nginx, and these are the volume mounts what I want to map to my volume. Okay, and this is my volume name and then the type of volume. Okay, now and here mount point slash data means this directory will get created inside our container. Okay, and this will be the logical name what I want to configure to my mount point. Okay, now let me save this and let us see what will happen. How to create a one pod? kubectl create or kubectl apply, right? So empty.dir.yaml, this will create one pod. If I'll do kubectl get pods, then we can see first pod one by one is up and running. Okay, now I want to connect to my pod. Xcc -it and then first pod and then bash. Okay, so what I have did, I have connected to my pod. If I'll do ls now, here we can see one directory called data has been created. Okay, this is our mount point to our volume. So what I will do, cd data. Okay, now let me, as of now there is no detail data available here, so let me create some random files, touch a b c d e f. Okay, so I have created 6 files over here at one location, that is slash data. So this is our volume directory. Okay, and same thing, let me again connect. Okay, let me go to tmp. Okay, here also let me create some random files, 1 2 3 4 5 6. So what I have did, I have created some files in tmp and some files in the data directory. Okay, so data directory is something related to our mtdir volume. Okay, now so I have created two different type of directories. Okay, our pod is running and we can see one slash data is also available. Our volume is also created. So now in order to test this, what I can do is I need to restart my nginx server. Then because I need, if I'll stop this, then what will happen, this will get terminate and it will create one new container for us, right? So let me try to create this one. Okay, so service nginx, or else before this let me show you the status. kubectl get pods. Here if you see, the number of restarts are 0, means this pod has not been restarted. Okay, so now let me connect to my container and try to stop my nginx service. Okay, service nginx stop. So what happened, this has been terminated. Okay, and If I'll check the pods, here we can see one restart has been available. So what happened? That has stopped our container and one new container has been created. If you want, we can also check the events. How can we check the events? By using kubectl describe and then the pod name. Kubectl describe pod and then pod name. Then we can see successfully pulled image started. Okay, so this is what happened after the restart. Okay, now one new container has been created, right? So if you want to test, then let me again try to log into my pod. Okay, if I'll do cd data, if I'll do ls, then I can find abcdef. These were created in the previous container, but still these files are already mapped to the newly created volume. So what is happening? This container has been created, but still this volume has been mapped with my container. Means whatever we are trying to create inside slash data mount point, that will be stored in our volume which is available inside the pod. This type of volume we call as mtdir. Okay, and I have created some files in tmp location as well. If I'll do ls, see these files are not available because this was not pointed to the volume, right? So tmp, I have created some random files and slash data is something related to our volume. Okay, understood? So what is happening? So whatever we are trying to store in volume, even if that container is getting killed and one new container is getting started, then still the data is available. This is what we call as volumes, persistent volumes. Okay, guys, understood?
Yes.
Yes.
Okay, so that's one thing. So, but the problem here is, problem with empty DAR is, if suppose for example, let me exit and let me delete my pod. kubectl delete pod. Okay, what I have did, now my pod has been deleted. Okay, now for example, if I'm trying to create one new pod, still the data will not be available. See, let us see by creating a new pod. It's same name, right? Hmm. kubectl apply -f mtdr.yaml. So one new pod again I have created. Now if I'll try to connect with cc -it first pod and then bash. Okay, data will be available because I'm using the same configurations. Data, if I'll do ls, no files are available. So what happened? So in this use case, the problem is if this pod is deleted, then there will be no data available because the volume what we were trying to use was inside this pod. If the pod is deleted and a new pod has been created, then there is no volume available. So this is restricted only at the pod level. Okay, so in order to overcome this such kind of issues, what we can do is we can use one more type of volume that we call as host path. Okay, so we create volume on host path, means volume will be created outside pod. So here itself if you see host means wherever we are trying to create our container. Okay, so for example, so this will be the case. Okay, so this will be our container, this will be our pod. Okay, this will be our host machine, for example node 1. Okay, so what will happen? We can create our volume over here, host path volume. Okay, so whenever a container is trying to add something, then what it will do, it will be adding the data to this volume which is available on the node machine, which is not available inside the pod. This time we are trying to store our volume or our data on the node machines. Okay, so here if this container is deleted for some reason, so what will happen, a new container will be created, but still it will be mapped to the same volume. Even if the pod is deleted, what will happen, a new pod will be created and that pod will be added to the same host path, because this volume is available on the node machine, right? So there will be no effect. Even if the pod is deleted or container is deleted, we'll still able to access our volumes. Okay, so let us see how can we configure this. Okay, so let me copy this YAML file and let me delete the existing pod. Delete pod -f1 vi host path.yml. Okay, same configurations. Again, the mount point is data. The volume name is first volume. Okay, here we are changing the volume type. So this will be the host path, and this will be the path where the volume is getting stored. Okay, so wherever this pod will get created, one directory will get created. Okay, so let me save this. Okay, and now let me try to apply kubectl create -f and then host path.yml. Okay, pod has been created. So if you'll do kubectl get pods, okay, one pod is running. I want to check where this pod has been created. Void. Okay, worker02. Okay, so now let me try to log into worker02 and check what happened over there. Okay, so let me go to instances. This is my worker02, connect, connect, and connect. Here in this document itself, I have given how to test as well. Okay, so you can check this. Okay, sudo su ifan. So this is my worker02, and where are we trying to store our volume in worker02? In the /tmp/data. Okay, so one file system should get created, tmp data. Okay, so this is where our volume will get created. Okay, so now let me try to connect to my pod and create some files. kubectl xcc -it and then pod name and then bash. Okay, now logged into my pod, and then this is my mount point, that is data. Okay, now if here if I'm trying to, as of now we don't have any files. Okay, so I'm creating one file, touch created inside pod. Okay, so what I have did, I have created one file inside the pod, and here if I'll do ls now, we can see this file has been stored on the worker02. Okay, for example, let me create one file here. Okay, created inside worker02. Yeah, now what I have did, I have created one file inside worker02. Now if I'll do ls inside my pod, then we can see this file is getting replicated. Okay, so what happened now, we have created one volume on the host machine. Okay, now for example, kubectl get pods, assume that this particular pod has been deleted. Okay, so let me try to delete this kubectl delete pod -f1 all. Okay, pod has been deleted, right? But still if you see this on the worker02 node machine, still the files will be available because these are stored on the host machine. This is not stored in the pod or inside the container, right? So the volume will be available. Now let me try to create one new pod again, kubectl apply, but this time it should execute on worker02 only because our volume is stored in worker02. Okay, so let us try kubectl apply f1f and then host path. If I'll do kubectl get pods f1 go, get pods f1 go void. Yes, again this has created on worker02 only. Okay, so now kubectl exec hyphen it and then first pod and then bash, and then if I'll do cd data ls, then we can find the files already available. So if our pod is created again, deleted and created again on the same host machine where we have created our volume, then the same volume will be mapped to our pod. Okay, so this is how we can use host path as well. Okay, so let me show you one more thing. So let me exit and let me make some change in my YAML file. Okay, so host path, but this data will not be available in worker01. This is available only and only to worker02 only. Okay, so if I'll make the changes, second container and the pod name also, I will be like, I will be changing this pod name. Okay, kubectl get pods and go wide. So already one pod is running on worker02. So now let me execute kubectl apply f1f and then host path YAML. Okay, second pod has been created. So here if you'll see, second pod has been created on worker01. Okay, now if I'll try to log into worker01, I mean second pod, so let us see what will happen. xec-it second pod bash. Okay, cd data, this is our point, right? So ls, no files are available. What happened if suppose we have multiple clusters? So this kind of behavior is good enough only if we are using single node cluster, means we have only one node machine. So what will happen, each and every time the pod will get created on the same node machine, right? But here what is happening, we have multiple node machines, the pod is getting created either on worker01 and worker02. If it is getting created on worker02, then this is well and good, means our volume is available over there only. If suppose my first pod has been executed on worker01, what will happen? Then we will not be able to access our data, means this kind of behavior is only accessible to the node where the pod is running. So if suppose this is my node 2, node 2, and again one pod is getting created here also. Okay, this container which is getting created over here. Okay, so there is no volume available on the node machine, and this container cannot access the volume from here. Okay, so that is not possible. So this kind of volume will be feasible only if we have single node cluster. Okay, and in production environments we are not going to see any kind of single node clusters. Okay, understood again. So mtdir, we are seeing one issue. We have resolved that issue now, but again with this host path volume we are again seeing one more issue. If you have multiple nodes, then this is not feasible. To overcome this, again we have one more option in Kubernetes. Okay, so understood. Okay, so in order to overcome this, okay, if we have multiple nodes, then we will other nodes will not be able to access the volume created on the node machine. Okay, so in order to overcome this, now what we can do, we can use Amazon Elastic Block Storages, EBS volumes. Okay, okay, again in EBS also we have some issues, so let us try to see how can we configure EBS storage. So what I will do is, I will be keeping my volume outside the cluster, means am not going to store this on my cluster. So let me show you this. So this is my master, right? So this is my master. This is my node 1. This is my node 2. Okay, now what I will do is, so this is my Kubernetes cluster. So initially what we have did, we have configured our mtdir volume in the inside the pod, and then we have used host path inside our node machine. So now this time what we do is, we will be configuring our volume outside the Kubernetes cluster. So I can use AWS EBS volume. Okay, so either it is node 1 or node 2, or if you have multiple nodes as well, then they can connect to this volume and they can store their data. Means this is not specific to pod, this is not specific to node, this is completely outside our cluster itself. Okay, so here, so if you have multi-node Kubernetes cluster, then in this case we need to keep our volume outside the cluster. If our pod is created on other node, then the volume should also be moved to the node. So what will happen is, so it should automatically move our volume as well. So earlier what we have seen, our pod was getting created on worker 01, but the volume was available on worker 02. So in this case, what will happen? This volume will get changed based upon the node. Means if the pod is configured to node 1, then the volume will also be assigned to node 1. If the pod is configured to node 2, then the volume will be configured to node 2. So this will happen if you are using AWS EBS volumes. Okay. So now let us see how can we configure this. But in order to configure this, first we need to, already we have set up one master, two worker nodes. Okay, and we need to log into our AWS account and create one EBS volume. So if you see this, my already existing cluster. Okay, so one master, two worker nodes, and here if you see this availability zone is US 1A 1A 1A. So now I need to create my volume on the same location, same availability zone. So let me go to volumes, create volume. Okay, volume type, that's up to us. Size, that's up to us, how much size of volume we want to create. So in my case, I will create 20 GB of size. Okay, and the availability zone US 1A, because all my instances are on 1A only. If I'll create in another availability zone, what will happen? Then again, I will face some issues in order to connectivity. Okay, so let me scroll down and create one volume. Okay, so one volume has been created. If you'll see this volume state, in use, in use, in use, means these three are already used by master, worker, and 02, and this is still free and available. If I'll scroll this, okay, this is available only, means no EC2 instance is being using our EBS volume as of now. We have just created, but this is not attached to anyone. Okay, so even if you remember the behavior of EBS, right? So to one EC2, one EBS can be attached, right? So now let us see the next step. So and then we need to create one IAM role for AWS EBS CSA driver. So what is this driver? So what happen is, if you want to create or store your data in AWS EBS, right? So we need to have that EBS CSA driver. This driver will help us to create volumes and attach that volumes. If we don't have this driver, then the clusters will not be able to attach the mounting point to the volumes. Means attached and detaching the volumes should be done automatically, and without this driver that is not possible. So we need to create one role for this driver. Okay, so if I'll go to AWS IAM roles. Okay, click on new role, create role. Okay, and AWS service, and then EC2. Select next. Here you can find AWS, EBS. Search this. Okay, you can find this policy. Copy this. Try to search this policy. This is already available in AWS. No need to create. Just search for this policy. Okay, select this policy next and create one role. Okay, if you'll see this, this will try to attach and detach our volumes. Okay, so here, so once you have created your role, then we need to attach our roles to the EC2 instances. So already I have created one role which is available on my account, so I will not be creating one new role, but this is how we are going to create this. Okay, so and then let me go to EC2 instances and select master. Okay, here if you will go to in security, as of now you can see there are no IAM roles configured, right? So let me click on actions, security, modify IAM role, and then let me select. So EBS driver policy. This is what I have created. Okay, so let me select this, update IAM role. Same thing I will be configuring for worker 01 and worker 02 because we are not sure where this will get created, right? So we should have this role so that we can attach and detach our volumes. Okay, worker 01 is also done. Worker 02, let me modify this IAM role, EBS driver policy, done. Okay, so now we have the role also created. And then we need to install EBS CSA driver on Kubernetes master node. Okay, so these drivers how to create, you need to use these steps. So let me use the same steps. It clone this part I need to execute on the master machine. Looks like my roles are being modified, right? So let me see. Wait. Policy has been attached. Everything is also good. Okay, connection has been reset. So let me try to log in again. So the issue. Okay. Now here if you see kubectl get pods, two pods are running. So let me just delete them. This is not required now. Cl delete pod -f all. Okay, so two pods has been deleted. So now what I want to do is I want to install these drivers so that I can easily use the EBS volumes as part of my volume. Okay, so git clone. So let me use these steps. This is downloaded, and then now let me try to cd AWS driver. Yes, And then we can use this command. What will happen? Basically, this command will also help us to create some pods only. Okay, it is also executing some pods. So run this. See, unchanged configure. Okay, some changes has been done, and if you want to verify, then you can see this pod. And where are these getting installed? In Cube system namespace. Okay, we have seen about different namespaces, right? So this is getting installed in Cube system namespace. Okay, and here if you'll see this EBS. Okay, so this is what it has been created. In my case, the timing is different because I have already set up this. But this is how you guys are going to create this, and once verified, that you can see these are being installed on 3 different node machines: worker master, worker 01, and worker 02. Okay, so now once we are done with this, so now let us see our YAML file. Okay, so let me copy this viebs.yaml. Okay, so this will be the API. Acha. So now we have something called PVCs. Okay, so the host path what earlier we have used, right? So we need to create one persistent volume. Okay, so this is also very important concept. I mean, this is part of volumes only, so we called it as persistent volume. So now what I need to do is I need to create one PV, one PVC, and one storage. So this is how this will be happening. For example, okay, so this is my EBS storage, what I want to use. And one PV will be created, persistent volume, and one PVC will be created. Okay, so if any pod wants to access this storage, right? So what will happen? It will, I mean, the PVC will claim the request. This PVC, this will claim the request to persistent volume, and persistent volume will try to create the storage. Okay, so now if you want to use this EBS, then we need to have one persistent volume YAML file created and one PVC YAML file created. So PVC means persistent volume claim. Claim means it is claiming that this wants to use the storage. PV is something which will help us to map with our storages. Okay, so now in this case, what we are trying to do is we are trying to create one persistent volume. Okay, the storage capacity is 10 GB. Okay, and the access mode is read write once. Okay, what's the persistent volume reclaim policy is retain. So we have different type of policies and different type of access modes available. Okay, and this will be the name. So in my case, I have configured as AWS EBS. Okay, and then this will be the block storage, and I need to configure the volume type. Okay, so what is our volume ID? So let me use this. Let me scroll back and go to my volumes. So this will be my volume ID, right? So this is my volume ID. Let me configure. Okay, and now let me save. I'm just renaming this to, instead of ebs.yaml, I'll use pv-ebs.yaml. Okay, so now if I'll do cat pv, okay, let me hide this. So what is happening here is we are trying to create one storage that is of 10 GB of size. Okay, and then the access mode what we can use is read write once, means only one pod can be used at a time. Okay, and then we have the retain policy, what we are trying to use, and then the volume ID. So now let me try to create this PV kubectl create -f and then PV dot EBS. Okay, persistent volume has been created. Here if you will see kubectl get PV, then here we can see my EBS PV. So this is our EBS PV what we have created just now. Okay, 7 seconds ago. Okay, the status is available, and as of now there is no claim configured here. Okay, and this is our storage class what we have. I mean, this is just a name. Okay, now as I said, if you want to use any storage, we need to have PV, and then we need to have PVC, persistent volume claim. Claim is nothing but this is trying to claim, okay, this pod needs to use this storage. This is what we are trying to add in the claims. Okay, so now if I'll scroll down, then we have one persistent volume claim for our EBS. So let me just copy this. Vi pvc dot hyphen EBS dot yml. Okay, the kind is getting changed here, and then the access mode will be same what we have used in PV. Okay, persistent volume, and then the storage class will be same. Okay, now let me save this. Now let me try to execute this kubectl create -f and then pvc dot ebs yaml. Okay, one PVC has also been created. Now, if we check the status, the kubectl get PVC. Now we can see one PVC has been created. Okay, and this is to map to the same storage name and to this particular volume. Okay, what we have created, my EBS PV persistent volume. This is has been mapped. Okay, if you see the status of PV now. Okay, now we can see the status as bound. Earlier it was available, now this is bound, and the claim which is trying to claim this storage is this particular claim. This is our PVC name. Okay, now both has been interlinked. So whenever we try to create any pod, what will happen? This PVC will be claiming this particular volume storage. Okay, so this PVC will try to claim this volume storage, and this volume storage will be using this volume. I mean, and what we have our AWS EBS storages, right? So now we have created this. Now let me try to create one pod. Okay, let me just copy this. Yeah, EBS pod dot YAML. Okay, same YAML file. What we can see, the only change is volume mounts. Okay, and then the type of volume. So here what we are trying to define is try to create one pod with the volume as persistent volume claim. The claim name should be my EBS PVC, means whatever we have configured in the previous claim. Okay, here what I have defined, the same name PVC name will be defined in the pod as well. So now what is happening whenever I am trying to create one pod here, if I'm trying to create one pod, what will happen, this pod will connect to this PVC because we have mapped the names of the PVC right in this claim. So and this PVC is interlinked with persistent volume, and this persistent volume will connect to the EBS storage. Okay, so this is what happening. Okay, now let me try to create some volume. Sorry, some pod here. kubectl apply f1f EBS pod YAML. Okay, created. If you see this kubectl get pods, then we can see one container is been created. This is still in pending state only. If you see this kubectl describe pod and then pod, because I want to check all the details here. If you see this, we are seeing some issues. Attach, detach controller, attach volume, attach failed for volume. My EBS could not attach volume to node. This failed. Expected device to be attached but was attaching. There is some issue in configuring this. Volume name is same, right? 0AE. This is in use means this has been already attached. Okay. So by whom? By worker 01. So there was some issue initially, but later on I think that has been resolved and it was able to attach successfully. Here if you will see this again, the details of the events, then the attached volume succeeded for volume 01. Okay. Now if I'll see kubectl get pods, I can go back. So what happened now? This pod has been created on worker 01. Okay, and this pod is been again using this particular volume. Okay, now this pod is using this particular volume which is already in use. So now if you want to store any data, for example kubectl exec -it my pod and then bash, then we can find the mount point, that is data. Okay, now if I'll create something, right, touch created in worker 02 pod, because this pod is running in worker 01, right? So let me create the file name with the same pod name. The only reason is for identification purpose. I just want to delete this pod and try to run one more pod again. Okay, so now let me exit and let me delete this kubectl delete pod -f1 all. What happened? This pod has been deleted. Now if I'll refresh this, now you can see this will be in available state. So let us wait for some time. Okay, if I'll wait for some time and if I'll refresh this is in available again. Okay, now if I'm trying to create one more pod, hopefully this time this should get created in worker 02. So let us try what will happen. Okay, again it has been created in worker 01 only. So even if it is created in worker 02, then what will happen? This will be using same EBS volume. If you see, this is in use. Now if I'll try to log in again, what will happen? We can already see the existing data what we have created. If I'll do ls, then this data is already available. So now if we are using multiple node machines as well, then it is not a problem. Why? Because our volume is outside the cluster. So any node can access our volume. So now the issue what we can see is, for example, now if I'm trying to again create ebs.yaml, so let me make some change here. I'm using my pod 1. Okay, I have changed the pod name. So let me try to create kubectl create -f ebs pod. Okay, now if I'll do get pods, this is executed on worker 01. Okay, and the just now what I have created is executed on worker 02. So what will happen now? This pod will not be able to create. Why? So let us check the error. What the error? kubectl describe pod and then pod name, my pod 1. Here if you'll see, multi-attach error for volume is already used by pod. So what is happening is, already my pod is using the volume. Okay, now if we are trying to create one more volume to the same one more pod to the same volume, then that is not possible. Means at a time only one pod can be assigned to the CBS volume. If we are using multiple pods to the same volume, then that is not possible. So again this is a problem for us. means we are not able to use multiple ports to write our data to the same volume. So only one port can be used at a single point of time. So now in order to resolve this, then again we can use same use case, but the thing is we will be using distributed file system that we call as elastic file system in AWS, right? So we have one concept in AWS, that is elastic file system, that is also part of volumes only. Okay, so now what is happening now, in order to resolve this issue, so we can use elastic file system storage. Okay, but before moving to that, so let me explain you a few things. If I'll cat my pv, so if I'll cat my ebs pv, right? So pv hyphen ebs.yaml, here we are seeing access mode as read write one. So what are the different type of access mode available, and what are the different type of persistent volume claims available? So if you see this document, okay, so we can have three type of access mode. One is read write once, one is read only many, one is read write many. Okay, and you can see the description. This mode allows the volume to be mounted as read write by a single node, means at a time one single node can be used. So in our case, just now what we have seen, we are trying to access multiple nodes to the same volume. So this is not available for read write once. So even if you see this PV what we have created, the mode is read write once only. If suppose I have changed the mode to read write many, this will not be supported to EBS volumes. This mode kind of mode is not supported. Okay. So for one EBS, we can use only one node at a single point of time. We cannot write multiple node machines data to the same EBS. Okay, that's the reason we were trying to use read write once. For any reason, if you want to change this to read only many, then this will not support for EBS value. It will directly throw error when we are trying to create one PV. Okay, so now we have three type of different modes, that is read write once, which will help us to allow to read write by single node. Okay, it is suitable for scenarios where only one node needs to read write access to the volume, such as with a single instance database, means only one node, then it will be helpful for us because this is already attached. Okay, and then we have read only many. This mode allows the volume to be mounted as read only by multiple nodes simultaneously. It is suitable for scenarios where multiple nodes need read only access to the volume. So what we have seen in the RDS, read replicas, right? So this is kind of situation. If we want to attach only for read operations, then we can use read only many configuration. Okay, such as for shared logs or configuration files, if you want to share the log files. Okay, and then we have something called read write many. This mode allows the volume to be mounted as read write by multiple nodes simultaneously, means if we have two node machines, then two node machines can be attached to the same volume. The ports can be used to write any data and read the data as well. So it is suitable for scenarios where multiple nodes will be used to read and write, such as shared file systems or distributed applications. So in our case, what we are trying to see, we are trying to see the shared file systems. Okay, here if you'll see this, kubectl get ports -wo. Okay, this is still in container creating stage only, because the volume what we have tried to attach is single node volume, means that can be used as read write only, right? So the first option what we have used, read write once. Okay, so in order to overcome these kind of situations, what we can do is we can use elastic file systems, means read write many. This is what we can use, read write many. Okay, and these read write many will be supported by elastic file systems. Understood, guys? Will anyone response? I mean, I'm waiting for your response.
Yes or no?
Yes.
Yes, bro.
Okay. Okay. And then retain policy. So what retain policy I was trying to use, for example, cat PV F1 EBS. Okay, here if you see the persistent volume reclaim policy, I'm trying to use as retain. So how many different type of policies we can use? We can use retain. This will be the default policy. Okay, and then we can use delete, and then we can use recycle. And recycle is something what is which is been deprecated now. Okay, so retain means with this policy, the PV is not automatically deleted or modified when released. Means the persistent volume. If suppose now what I have did, I have created one EBS, right? So if no one is trying to use this, or if the pods what we have used has been deleted for some reasons, then the PV will be still available. This will not be deleted. Okay, so the EBS volume will be still available only. If you are trying to use this as delete, then the PV is automatically delete and the underlying storage resources are released when the PVC is deleted. Means once the claiming and the pods whatever we have created has been deleted, then this PV will also get deleted and we are going to lose the data. So that's the difference, and most commonly we will be using retain policy only because we don't want to lose our data. Okay, now in order to overcome this situation or such kind of issues, we need to have storages outside the network or outside the cluster, but it should be distributed across different node machines. Okay, so that's where we have elastic file storage. Okay, if our pod is created on other node, then the volume should also be moved to that node. So this is what it will happen in the EFS part. Okay, so now let me create one EFS volume. So let me follow these steps. So let me delete this one. So existing pods, let me delete kubectl delete pods f1 all. Okay, I have deleted my existing pods. This is in, this will be now in available state because I have deleted that pods. Okay, let me ignore this. Let me use EFS, elastic file system, create file system, and then name. So let me use ATS EFS. Okay, this will be my file system, and this will be the VPC where we want to create and create. So what I have did now, I have created one elastic file system with the name called KATS-EFS. Okay, so the thing here is in EFS we haven't specified any size. I haven't specified any size. So what is the size of this EFS? So elastic file system, it means elastic means basically this is stretchable. So for example, I have stored 1 GB of data, then it will use 1 GB of space. If I want to add some more data up to 10 GB, then this file system can be stretched to 10 GB. So whatever we are trying to add, based upon that, this will be accepting the data. So there is no fixed storage for EFS. This can be stretched as per our usage. Okay, so EFS, if I'll click this here, you need to see one thing. If I'll go to network, okay, here you can see this elastic file systems are available in US 1A, 1B, 1C, 1D. In all the regions, this has been available. But whereas for EBS, if I'll go to EBS, let me show you something. Let me go to volumes. Here, if you'll see this volume is restricted to 1A region only. This is available in 1A only. If suppose my cluster is in 1B, what will happen? We will not be able to access this EBS because of different availability zone. That's the problem with EBS as well. So, but whereas for EFS, this is getting created in all the regions. Okay, means this is available in 1A availability zone, 1B, 1C, 1D of North Virginia. So, overall North Virginia, this file system is available. Okay, now once we have created our EFS volume, create one access point to our EFS volume. So, how to create one access point? Just go to access points, click on create access point. Okay, so test EFS is what I want to give. Okay, and this will be the optional. I will not be using anything. I will not be using any details over here as well. Just click on create access point. So what I have did, I have just created one sample access point. Okay, so without any permissions, random access point. Okay, so this is also done. Now we need to install EFS CSA driver. Earlier what we have installed? We have installed EBS CSA driver. So now if you want to use EFS, then we should install EFS CSA driver. So earlier what we have did, we have created one role, but here we are not going to create any role, but we are trying to just use EFS CSA driver on master machine. So how to do this? So we have some steps. Copy git clone. Okay, so this is done, and then apply the CSA driver manifest, navigate to the clone part. So let me copy this command now. Okay, so currently I'm into this location stable, and then let me execute this command kubectl apply -k dot. So what will happen? This will try to create our pods. Okay, unchanged, something happened, some pods has been created. How to verify? Then we can verify from this command kubectl get pods, same namespace. This will also be configured in the namespace called kube system, and we are trying to filter only to this specific node. Okay, so or let me do one thing, let me only check the pods which are available in the namespace called kube systems. Here if I'll do here, so here we can see something related to EFS. Okay, so these are my drivers which are running on to create the elastic file systems automatically. Okay, so this is related to EFS, and this were related to our EBS. Okay, and here if you'll see this, let me do some more. F1 wide. Okay, here if you'll see this EBS1, these are being executed on all the three machines: master, worker 01, worker 02. Means this driver should be run on all the three node machines. Okay, so now we have got our drivers as well. Okay, and then what I need to do is I need to create one provisional storage class. Okay, so for what purpose the storage class is used? This will help us to automatically, I mean, see, dynamically provision EFS volumes. So whenever it is required, then this driver will again help us to provision. This EFS provisioner will help us to create our volumes on EFS automatically. Okay, so let me create one storage class YAML. I think already this is available. Storage class YAML is already available. Okay, if I'll cat this, okay, this is configured over here. So I'm configuring one EFS driver and then provisioner. So what this provisioner will do, this will help us to create our volumes. Okay, so now let me try to execute this. Okay, this is also running. If you want to check kubectl get SC, storage class. SC means storage class. This is the shortcut. Okay, here we can see one provisioner, and this is the name EFHFC, what we have configured. Okay, and allow volume bonding and all, and this age is 41 hours, means yesterday's duration. Okay, and then we need to create one persistent volume for our EBS. Okay, so let me copy this. Same again, we need to create. So we have our storage now. We need to create PV, we need to create PVC, and we need to create pod. Okay, so now let me create this VIEFS-PV.yml. The only change here, access mode is read write many, and the storage capacity what we are trying to claim is 5 GB. Okay, this will be the name, and here I am configuring the provisional driver name. So what we have created just now. Okay, and then here I need to configure the volume ID. Okay, so from where I can get this volume ID? I can get my volume ID, file systems. Okay, this is my file system ID. So let me just copy this and paste here. And this EFS access point ID. So from where I can get this access point ID? So let me copy that as well. Okay, so let me just go to access points. If I click here, then I can find this access point. Okay, here I can see this access point ID. So let me copy and let me paste. Save. So once this is done, then let me apply kubectl apply -f efs.pv. What happened? kubectl get pv. Okay, this is already running. Yesterday what I have created for testing, so this is already running. So that's the reason it is not allowing me to create one new with the same name. Okay, so that's okay, this is already running. So this is how you need to create your PV. Okay, so once this is done, then what we need to do, we need to create one PVC. So this will be our PVC. Okay, so once we have created, in my case PVC is also available. So if you see this kubectl get PVC, the PVC is also available. Okay, read write many of access has been provided. Okay, so PVC is also available. And then now if I'll try to create one pod, so let us see what will happen. Okay, so just try to copy the YAML files and execute, then you will be able to create the PV and PVCs. Okay, so now let me execute my pod via efs.yaml. Okay, this will be the mount point. Okay, and this will be the claim what we are trying to use. Okay, and if I'll again do cat at efs.prod, so this will be the directory which will get created inside our container. Okay, so let me try to execute now. kubectl create -f, and then what was our file name? efs-pod. Okay, one pod has been created. So if you check the status, kubectl get pods -o wide, then we can see one container is been getting created. So it will take some time. So let us wait for this. Okay, or else till the time, let me check describe command, kubectl describe pod, and then the pod name is efs-pod. Here if you see this, you should not perform authorization, something is happening. Okay. One second guys, let me just plug in charger to my laptop. So what happened is, here we can see some non-authorized perform has been happened. So we have already configured one EBS driver policy to our existing role, right? So because of that, it is failing. Okay, the container is still in creating state because our EC2 role is not allowing us to do this. So what I will do is, I'll just go to my EC2. Okay, and I will modify the role. Okay, so I will just remove this actions, security, modify role. So I will remove this role and I will keep empty role. So there will be no role required. Detach, done. Okay, same thing. I will do this for worker 01 and worker 02 as well. Okay, actions. Detach. Okay, now what I have did, I have removed the policies what we have already configured. Okay, so let us see what will happen. Now if I'll try to see the status, okay, and check the events describe, then it will take some time, but these changes will get reflected. Or else let me try to do one thing, kubectl get pods, kubectl delete pod f1 all. So let me delete the existing pod and let me try to create one new pod again. This is getting terminated. Okay, so let me create one new pod, not a deleted. This is taking some time to delete the existing one. kubectl get pods. Why it is taking a lot of time? Okay, let me do one thing. Let me modify my existing one. I'll change this YAML. What will happen? One new pod will create it, right? Pod one. Okay, just changing the pod name. That's it. So if I'll use same YAML to create, one new pod will be created. kubectl get pods. Container has been getting created. If you see this kubectl describe pod and then pod name, that is EFS pod one. Successfully assigned, but still mount volume setup failed for volume if it's PVC error. So this time this is getting failed. Okay, the namespaces container is still in creating mode only, not yet created. Okay, let me do one thing. kubectl get pv. Okay, so I'm deleting the existing PVs. So already this has been created yesterday, right? So I haven't created now. So let me delete the existing one and try to create some new persistent volume claims and persistent volumes now. Guys, any questions? This is easy or confusing? డే 1 నుంచి లాస్ట్ డేలో వచ్చినాం ఈరోజు. ఆనంద్ ఫోన్ చూడడం మానే. What happened? This is also not deleted or what? kubectl get pods. Container is still getting created. kubectl delete pod and then what time? Okay, the issue was because yesterday what I have created, that was also for file system, but that file system ID has been changed. Okay, the PV what we have used today, that is different and these configurations are different. That's the reason we are unable to create. So first let me delete my existing configurations and then let me try to recreate one. kubectl get pvc. Yes, let me delete this as well. kubectl delete pvc and the pvc name is efs pvc. Okay, one PVC has been deleted. Now let me check. Okay, PV is also deleted. Now if I'll see my pod is also deleted. Okay, so now we don't have either pod, either PVC or PV. So now let me create one PVC first. So we have already created, right? I think yes. Cat efs hyphen pv.yaml. Okay, so this is my. Let me cross check the IDs, file system IDs. Okay, so 578, 578. AAT and AAT. Okay, so now we have our PV. So let me create this kubectl create -f and then efs pv.yaml. So we have created one PV and now let me create one PVC, that is persistent volume claim. So let me copy this via efs pvc.yml. Okay, so kubectl create -f efs pvc. Okay, this is also created. Now let me create one pod. So we have already the pod.yaml configuration, right? So where is that efs pod? So let me first check that efs dot pod. Yes, this is also available. So now let me try to create one pod now. kubectl create pod hyphen efs create hyphen f efs hyphen pod dot yaml. So one pod is created. So let us see what happened. Get pods, that pod, and then pod name. Okay, started container. Okay, again if you see get pods, then we can see this time our pod is up and running. Earlier the issue was with the ID what I have used. Okay, so now if I'll try to connect to my pod exec hyphen it and then my pod 1 bash ls, then here we can find one directory called, sorry, my pod 1 is not available or what, not yet connected. Okay, efs pod 1. Okay, so let me change this name. Okay, so now if you see this here, we have got one directory called efs pod because this is what I have created, right? Here if you see this efs mount, so this was my mount point. Okay, so now inside this directory what I will do is I can store any configurations, for example touch pod 1. So this is my pod name, right? So I'm just creating one file name called pod 1. So I have exited. So now let me try to create one more pod. This time the pod name will be pod. Okay, and the remaining details will be saved. So if I'm trying to execute my YAML, okay, now if you'll see kubectl get pods -o wide, then we can see two pods are running on two different machines, worker 01 and worker 02. But still they are up and running. So what happened now? Multiple nodes are able to access same volume which is outside the cluster. In EBS, what happened? Only one node can be accessing our volume at a single point of time. But now multiple pods are running. So what I have did, I have first created pod 1 and I have created one file called pod 1. Sorry. What I have did, I have created one file called pod 1 in my pod 1. So now let me try to access my pod 2. kubectl exec -it and then efs-pod bash, and here if we'll do ls and then the mount point, here if we'll do ls, then what we can see, we can find the file which we have created in pod 1. Okay, so now what it means, both these nodes and the pods are using the same volume. Okay, so this is how we can configure efs for multiple node machines. I mean for multiple nodes or for multiple clusters. Okay, so now we have overcome the existing problem as well. So now this is one of the solutions what we can generally use in Kubernetes if we have multiple clusters available. Okay, same concept we can use in EKS as well. I mean sorry, yeah, AKS, Amazon Kubernetes Service. We will be using same file systems and the same drivers. So whatever driver I have used, right, so EFS drivers, so that will be by default available if we are using Amazon Kubernetes Service. Since I am not using the service, what I have did, I need to install all the drivers. If you are using the existing service, then no need of creating this. Okay, but the process will be same. I mean you need to create persistent volume and then persistent volume claim and then the pod YAML with the persistent volume claim. So this will be the same procedure if you are trying to create any persistent volumes. Okay, but the problem here again with the file systems is the cost of file system is very high comparing to that of EFS. Okay, sorry, comparing to that of EBS. If suppose EBS is costing 1 rupee per hour, then EFS will cost 3 times higher. And this will be used, this will be built based upon the storage what we have used. I mean, if suppose we have 100 GB of data, then it will be, the cost will be built only for that 100 GB. Okay, but whereas in EBS, if the volume is of 10 GB of size, then it will be, if whether we are using or not, then the billing will be for 10 GB. Okay, so that's the difference over here. Understood?
Yes.
Okay, and then we have something called daemon sets in Kubernetes. Okay, so I will not be creating any daemon sets now. Let me just show you something. CTL get pods -n cube system, sorry, cube system namespace. I just want to check here. If you'll see this, we are able to see 3 same nodes, EFS and EBS. I have created these drivers, but I haven't mentioned anywhere about the daemon sets, right? So for example, let me show you one more thing. Kubectl get daemon sets or DS. We can use daemon sets or DS. Okay. So here what happened? As of now, do we have anything? Okay. So now, what do you mean by daemon sets? So daemon sets are nothing but same pods. It will only ensure that these pods are running on all the 3 machines. I mean, as of now we have 3, right? So this will only make sure that our pods are running on the number of nodes available. Means, if suppose, if you'll see this, daemon set is a type of workload that ensures that a specific pod, one pod is running on each node in the cluster. If we have 2 nodes, then it will be running on 2 machines. I mean, 2 nodes in the cluster. If we have 3 nodes in the cluster, then this pod will be running on all the 3 nodes. So how to create this? So let me just copy. Same pod configuration, the only change will be in terms of the kind and the API version. Other details will be same. Okay, so let me copy this vi daemon set.yaml, and if I'll paste this, hit enter. Okay, and if I'll try to execute this, kubectl apply -f daemon set.yaml. kubectl command is wrong, so it has thrown error. So what happened now? One daemon set has been created. kubectl get ds daemon sets. We can see the daemon sets has been created. So how many nodes are available? We have 2 nodes. So here if you see, the desired state is 2, current is 2, ready is 2, up to date is 2, available is 2. Okay, if I'll do this kubectl get pods, then here we can see 2 pods are been running. So if I'll show -o wide, then we can see this is running on worker 01 and worker 02. So what happened if daemon sets? I mean, what do you mean by daemon sets? Is nothing but daemon sets will ensure that one pod is running on all the node machines. Okay, so daemon set will always ensure that the pod is running on all the node machines. But what is the use case? Why do we want to use daemon sets? There will be some situations where we want to check the logs. I mean, for monitoring tools, for log monitoring tools, we need to have a specific service which should be running on all the node machines if we want to track the logs. In that case, we can use daemon sets. If there is any requirement for your application that one pod should be run or executed in all the node machines, then we can use daemon sets. Earlier what we have did, we have used YAML and this was executed on worker 02 or worker 01. But whereas for daemon sets, we haven't specified our node machine name or the node selector or node affinity. It is directly executing on the number of worker nodes. Okay. For example, just see this kubectl delete pod, and then let me copy. Let me try to delete one pod with the name called QR4. So let us see what will happen. Demonstrate sequencing. See, again the desired is 2, everything is 2. Here it was 2, I have deleted, but still it is 2. So what happened? So if you check these pods, we can see 14 seconds ago one new pod has been created. So what happened? So this will always ensure at least one pod is running on all the node machines. Even if you try to delete this, then this will get created. The only way to delete this is to by deleting the daemon set itself. For example, kubectl delete ds, and then the name of the daemon set is example hyphen daemonset. Spelling mistakes. Okay. Now if I'll do get pod, so let us see what will happen. See, daemon sets has been deleted. Okay. So this is also very important as part of interviews. They will be asking all these definitions. Okay. And then we have, guys, this is understood. నోట్ తెలిసి ఎస్ నో ఏదో ఒకటి చెప్పండా, ఎందుకు మరి సైలెంట్ గా కూర్చొని.
Yes.
Okay. So now we have something called liveness probe and readiness probe. Okay. So why do we use liveness probe and readiness probe? So this is our last concept in Kubernetes. I mean, in our training. Okay. So we have Helm charts and we have ingress, egress, and we have load balancer. So that part, as of now, will not be covering that because that is not much important. Okay, so we'll be stopping with this only. Okay, so now we have something called liveness probe. So why do we use liveness probe? What do you mean by liveness probe? So what is happening is, so all these days what we have did, we have created some pods. Okay, if you see this, so we have created these pods and all this stuff has been done. So now just let me delete this existing one. Digital delete pod F1. Okay, so what we have did, we have just created the pod, but we haven't checked the monitoring part of the pod. So if you remember in load balancer topic, what we have did, we have seen the health check of the EC2. If the health check is not good, what will happen? The EC2 will get restarted or some any action will be happening, right? So similar concept we have in Kubernetes that we called as liveness. Liveness means alive. Okay, if the heartbeat is okay, then it means that the person is alive, right? So similarly, if the health check of the pod is okay, then it will assume that the pod is healthy. Okay, if for some reason the pod is not healthy, then what will happen? Then it will restart the pod. Okay, so if suppose the pod is not healthy, then it will try to restart the pod again. That we called as liveness probe. Okay, so here we have one sample example. If you'll see this document, so this is our image name. Okay, and nginx generally it will work on which port number? That is port number 80. And in liveness probe, so this is what I will be configuring. Okay, and then what kind of request? So I'm using http get, and this will be the health check path, and this will be the port number on which the health check will should be happening, and then initial delay seconds and period seconds. So this is something what we'll be adding. Okay, here in instead of http get, what different options we can use? we can use TCP socket or EXEC to execute any command. Okay, instead of HTTP, we can use TCP socket if it is for TCP protocol, and then or else we can use EXEC if you want to execute any command and check the health check. Okay, this part you can try to do some R&D and check how this can be configured. And then the path of the health check. So forward slash means root. If you have any file, for example index.html, what you can do, index.html. So this is what you can configure. Okay, and where it should check for this file, they should check from port number 80 only, because Nginx works on port number 80, right? So initial delay seconds 15 means it will take 15 seconds of time to check the health check. First time it will wait for 15 seconds. We can reduce the time if you want, but this is what this means, that it is waiting 15 seconds to check for the liveness. Okay, period second means for every 10 seconds it will try to check. Okay, so if I'll execute this script, what will happen, one pod will get created and the liveness will also be up and running. Okay, so for example, if I'll copy this pod.ml. Okay, so let me use this pod.ml. Okay, let me replace this. Okay, kubectl, apply -f, and then pod.ml. So what happened, one pod has been created. If you see this, get pods, sorry, command. Okay, one pod is running. If you see this, kubectl describe pod and then my pod, then here we can see after some time it will show us the events of the liveness as well. Apart from this, here also we can see liveness, HTTP get request, HTTP, and then this can be the IP of the our container, and then the port number 80, and the forward slash means this will be the health check. Okay, so the time what I have configured is 15 seconds, timeout is 1 seconds, default period to check is 10 seconds. Okay, and the number of success failures, this is commented. Okay, so from here we can see what is happening. So describe pod my pod. As of now everything is good with this image, that's the reason it will not get restarted. Okay, here also if you see this, restart count is 0, get pods restart count is 0, because this is perfect example of our YAML. So there is no error, then this will not get failed. The health check is getting passed, so it is not getting restart. So how to test this? If you want to test this, then I am just changing the configurations from 80 to 8080. Okay, because Nginx works on port number 80. So on port number 8080, it will not find anything to check. So what will happen? This will get failed, and then we can check if this is really restarting or not. Okay, so let me copy, and before doing, if I check this, okay, this is working fine. So vi pod one.yml, or else let me use the existing pod.yml. Okay, so let me just make the changes to the existing one only. And just change the timing for 5 seconds, 5 seconds, and this port number where it should check is 8080, which is not possible for Nginx image, so this should get failed. Okay, and then the pod name, what I will do is failed pod. Okay, I'm just changing the name as well. So if I'll execute this, kubectl create -f and then pod.yaml. So one more pod has been created. So if you'll see kubectl get pods, kubectl get pods, then we can see one failed pod is running, one pod is running. So what will happen? So it will wait for 10 seconds and then it will restart. Here if you'll see, the number of restarts is 0. kubectl describe pod, fail pod. So here if you see this liveness prop failed. After 10 seconds, what happened? This has been failed. And if we scroll up here, we can see a liveness that is trying to check on port number 8080, and one restart has been done. Okay, so this is how liveness will be working. Here if you see this, see restarts, number of restarts, how many restarts has been done? 3 restarts has been done. So it will continuously try to restart our pod again and again until and unless we have configured this properly. For example, now if I'm making these changes, okay, 80, then what will happen? The health check will should get passed, right? So kubectl apply -f pod.ml. So, because we are not making any changes in the container, so this will not be working. Apply. Okay. So for what I can do is I need to delete and I need to create one new container. Sorry, new pod. Okay. So kubectl get pods. This will continuously restart our container. So this is what we called as liveness. So liveness means it will check for the health check of the container. If the container is healthy, then it is well and good. If not, then it will restart our container. That's one thing. And then we have something called readiness prop. Readiness means this is also used for pod configurations only. So this will check if the container, sorry, if our pod is healthy or not. Okay. If our pod is not healthy for any reasons, then it will make this as not ready status, and this will be not serving the traffic. Means if suppose we have configured one service and these pods, if the pod is not ready and if you have configured liveness, what will happen? What is happening here? It is trying to restart our container again and again, and then one crash loopback off has been happened. Crash loopback off means specific duration which is trying to restart and restart. So that this kind of error we called as crash loopback. Okay. So what is happening here is it was trying to restart again and again, but whereas if we are using readiness, then it will not make the traffic to redirect to this port. Means this will be not ready status. So this status will be 0 by 1 if we are using readiness. Okay, so let us see that example. So this is one file. Okay, so index.html will be the default file available in Nginx, right? So let me use the same file, vi readiness.yml. I'm just using one new YAML file. Okay, and let me change the pod name as well because already this pod is existed, so this will not be running. So readiness. So other details are perfectly fine, and the only thing what we can see is instead of liveness here we can see readiness. Okay, now let me execute this kubectl apply -f and then readiness YAML. API version not set. What happened? There is some error. I haven't configured the API version, so let me check. Okay, let me configure the API version, save, and let me execute. kubectl apply -f and then readiness.yaml. Now what happened? One pod has been created. If you see this kubectl get pods, we can see readiness one pod 0 by 1. Basically, it is checking for the health check, and then this will be ready. See, one by one now because the health check has been passed. If you see this document, index.html is the default file which is already available, right? So the health check is getting passed and it is running on port number 80 only. So this is ready to serve the traffic. kubectl describe pod name, describe pod name. Then we can see readiness over here. So it is checking on HTTP request port number 80 index.html file, which is available. So what I will do is, in order to test this whether this is working as expected, or to prove this, what I will do is kubectl exec -it, and then pod name is readiness bash. So what I'm trying to do is, inside, so we have the default index.html file, right? So because of that, the health check is getting passed. So I will delete the default index.html file. So what will happen? And then readiness will check if the health check is getting success or not. So the health check will fail, and our pod will be not ready status. Okay, so let us see. User share nginx html ls. Here we have one index.html. So this was the file which is this trying to check. So let me delete this. Okay, I have deleted now. So let us see what will happen. Hyphen watch. Okay, here this pod, you just check this pod only. Okay, see 0 by 1 failed pod. So this is failed pod. So this is readiness pod, which is not ready status. Why? Because the health check has been failed. If you want, I can show you the events by using describe. Okay, readiness profile unhealthy. So once it will check, okay, the container which is running our application is not healthy, then what will happen? It will not serve the traffic. Whereas for liveness, what it will do, it will try to check the health status of our container, and it will restart the container if it is not healthy. And whereas readiness, it will restart our, sorry, it will not serve the traffic. Okay, so with the help of liveness and readiness, what we are trying to achieve is, we are trying to achieve the status of our container and the application. If our container is healthy and the application is healthy, then only the traffic will be redirected, or else it will be in not ready status. Understood?
Yes or no?
0 by 1. Okay, I think I have taken a lot of time, and with this we are going to close our Kubernetes concept. Okay, so if you have any questions, then let me know, or else I will be stopping this recording. Okay, let me stop.